Welcome to From the Spectrum podcast. This is a podcast about autism. It is my goal to explain what is autism. I plan to use a mixture of scientific literature, personal experience, and opinion. With opinion, I will explain why I feel the way I do and give examples. I will provide links to various references for each episode. For each episode, we will discuss various aspects of autism. For today's episode, we will explore eye tracking as an early biomarker of autism. When I say early, the studies are on infants or toddlers. We've covered autism in the embryo, and we've covered 2 studies on 6-week-olds, one from UC San Diego on brain organoids, and one from UCLA on the salience network connectivity. In addition, we've covered autism and the salience network. All of these conversations are entangled. In addition, a vital conversation is brain development from the eyes. Some regions of interest include vitamin A or 11-cis retinol, opsins, especially melanopsin. Remember, melanopsin wasn't discovered until 1998. That does not mean it is new in our biology. It was just not discovered. Melanopsin predates chordates. All opsins and 11-cis retinol, or the vitamin A, have weak covalent bonds. We've covered the most important item, light. Both sunlight and artificial light. The spectra and lux are everything here. Sunlight is 280 nanometer wavelength to 3100 nanometer wavelength. And artificial light are specific or isolated wavelength. For example, most modern light is blue light wavelength, 440 to 480 or so nanometer light. Remember, this isolated blue light breaks that covalent bond of vitamin A and opsin and creates free radicals in the aldehyde form. This is very damaging in the mitochondria. What does this mean? Light is an electromagnetic field, or EMF. Our mitochondria are driven by light, and specifically the electrons. Aldehyde in this form are toxic to the lipid rafts and cell membranes. In other words, it complicates the electrons. And cytochrome 1 is electron transport chain. Now just imagine the downstream processes of the other cytochromes and cytochrome C oxidase, where water is very crucial. How it destroys the membrane is by demolishing human photoreceptors, which we have more than what you think. Also, critical for the eye tracking episode, melanin, tryptophan, water, which is more mitochondria in that cytochrome C oxidase, and melanin. Most of this is mitochondria and melanin. Remember, tryptophan is an aromatic amino acid absorbing light, 200 to 280 nanometer light. These components are crucial for development and biological functioning. Before we get into the downstream topics, eye gaze, joint attention, and so forth, remember those are downstream, at the point we can notice, observe, and attempt to connect some pieces of certain phenotypes. Then, science can work towards understanding what it means. We love to go here, more so than going upstream with those biological processes I mentioned in the eye for brain development. Other key points. The eyes are brain, and the eyes and eye development is vital for brain development and brain health. Remember, you can get an OCT scan, and it shows upstream problems of brain and body diseases much earlier, years earlier in some cases, of the disease phenotype. In other words, the symptoms or conditions that certain diseases create. Melanopsin and retinal ganglion cells, especially at 3 and 6 o'clock, and the choroid plexus are areas to target on an OCT. Things like dementia, obesity, and diabetes can be seen here. The choroid plexus accounts for 85% of blood in the eye. The eye is very metabolically demanding area for nutrients, oxygen, glucose, and so forth. Remember the layperson example. People that stand up too fast or strain too hard can get lightheaded, fuzzy vision. This is vasovagal. In other words, those nutrients, the oxygen and glucose, didn't get to the choroid plexus fast enough. This also considers cerebral spinal fluid, or CSF. Okay, lastly on the biology, and it is important. I mentioned melanin. People think iris, skin, and hair color, but there is so much more. The optimal way to charge separate water is melanin. This creates free electrons, faster and more plentiful than any other process or component. The powerhouse to the cell, this is in the mitochondria. Also remember, melanopsin has now been discovered all over the body and the brain, deep inside the brain, inside of tissues and epithelial, and inside of organs. This is everywhere. Nonlinear optics controls our biochemistry. These components that we discussed is in charge of our biochemistry. This is what we have been discussing so far in the episode. If and when the eye isn't developed, the brain and body won't be developed. At least not optimal. If and when the eye ages or becomes damaged, it breaks down. The brain and body becomes damaged. It's that simple. A lay public explanation or an example is, if you have a fruit tree and you block the sun from the fruit tree, it could still produce fruit, but the amount of fruit and individual pieces of fruit will be damaged. It will drastically change the production of the fruit. However, if you give it full sunlight, the way it has evolved to need, then you will have a better outcome, more optimal fruit production. This is similar to how the human body is working. It's this simple. Eye tracking in autism as a biomarker. This is area of research I agree with. It is number 2 on my list of importance behind the cause of autism and above longitudinal studies of autistic adults. Remember the wonderful story of Jonathan Mitchell, now 69 years old, autistic. The purpose of eye tracking is having a biomarker as soon as possible to identify autism and begin interventions. It also, as we discussed earlier, it informs research of what is autism. So with interventions, it is no surprise the earlier the diagnosis and interventions are applied, the better the outcome. Here, outcome to me is being able to navigate society, not based off of social norms, but in a way that is manageable for the autistic individual. We speak about neuroplasticity, how we become who we are as a living and changing living organism. If we zoom in, this would include the ability to do certain tasks, have certain preferences, enjoyments, and dislikes, have intelligence, motor functions, and these learning skills are all essentially infinite. Infinite to the point of the individual living organism lives in its full potential. In reality, never does a living organism fulfill its full potential. And we can make a counterpoint for neuroplasticity here as well. We experience negative outcomes, and we can be self-debilitating. Humans think like no other creature. We have that capacity for human thought, and this takes us to wonderful places, and it can severely hold us back. No other species or living organism can put itself in harm like we do, and it's not even close. But know this does not determine valence or how we feel about life. It's wise to always strive for higher goals, to move our potential in an upwards trajectory. Now let's zoom out with an example of neuroplasticity. This is easy. This is autism. Autism suddenly shows up in the first parts of the 1900s. Remember, autism is a biological adaptation to the environmental change. Likely, in my opinion, changes in light source and energy. Remember, we ought to look at using the basic concepts of human life and altering one of those, and then see what it creates. Not adding something to the process like pesticides or toxins, neurotoxins, or vaccines, or BPA and plastics. Those are all topics of interest, but something not as demanding or debilitating, in my opinion, and others' opinion, about what light can do. And to add, you can look around at society, and everyone's following this light. Everyone is involved in this change of light, and this health complications are out of control. If areas or regions of the world add artificial light and more technology, disease shortly follows. It's not that complicated. A layperson example is India and type 2 diabetes. Okay, back to the eye tracking. There are a few items we will cover. Social attention, gaze following, and joint attention. Social attention are faces, learning and remembering faces. As an infant, much of what we see are faces. Everyone wants to see the baby, and everyone wants to see the baby smiling. So the other face typically laughs, smiles, and alters its voice. A side note, that altered voice is to adapt to early evolution of speech and language, because that's the trajectory or the placement of the baby. And remember, song and dance predates speech and language. Remember the roles of oxytocin and vasopressin in the autistic phenotype, and the differences between magnocellular and parvocellular paths, and distinct characteristics with socialness. For example, magnocellular is responsible for parental attention and emotional, or sometimes called affective empathy, meaning once we are told what the other person is feeling, then we respond. Then our empathy increases and we can share that. Parvocellular is responsible for pair bonding, more peer-to-peer, and cognitive empathy, sometimes called theory of mind, when we can look at someone and understand what they're going through. Remember, cognitive empathy is more guessing. It's more gray area. We don't know. But emotional or the affective empathy is conveyed directly to us with no guesswork, no gray area. It's very rigid. Now, hopefully, you can understand why autistics are typically low in the guesswork empathy and high in the conveyed direct empathy. Okay, autistics, it seems at all ages, prefers objects over faces, and objects over faces on joint and gaze attention. Likely, objects are less active, less sensory processing, and lower rates of information in the sensation and perception processes, which also involves magnocellular and parvocellular and visual pathways of the lateral geniculate nucleus of the thalamus. I have no doubt this is a region of interest or cause. Gaze attention. Around 6 months, infants begin gaze following. This is explained in Autism and Adaptive Responsive episode and other discussions around social cognition and building social skills. The medial prefrontal cortex and the amygdala. This is crucial in the communication between criteria B, the more innate, self-satisfied, restricted, fixated interest criteria, and criteria A, the social communication and interaction. Joint attention. This is essentially gaze attention to me, but this involves sustaining attention and sustained effort or ability to stay with the other, singular, or others, plural. Joint attention also encompasses body language, components towards the cue, the social cue, those items that have flexible meanings, or said differently, are context dependent. An easy example is how long eye contact lasts. The length of eye contact means different things. Great. Who determines this stuff? These social norms are hilarious. But these are things across cultures, across the world. It's a wild component of the speech and language dynamic through multiple cultures. They all have different meanings. Some notes to mention. These are infants, so early diagnosis presents many challenges with assessment and understanding specific phenotypes of the infant. A part of assessment is clinical judgment, and eye tracking provides objectable data that can remove certain weight of clinical judgment. Always a good thing. At this age, instruments in the process, because the infant cannot do too much and is very limited. But with the data on autism in the embryo and the neurological studies at 6 weeks old, This is adding up as a crucial epoch for autism diagnosis. 4 scientific literatures to review. 4 that I selected. These are not the only 4. You can go to PubMed or even a search engine to discover more. One is Pierce et al. From 2019. One is Keehn et al. From 2024. Rudling et al. From 2024. And Wien et al. From 2022. All available in the show notes. We've covered Pierce and UC San Diego with the embryo and the brain organoid predicting profound autism at 6 weeks old. And a previous guest, Jonathan Mitchell, participated in studies within this group. Pierce et al. Objective: examine diagnostic stability of toddlers starting at 12 months old. The study used data from January 1st, 2006 to December 31st, 2018, equaling 2,241 toddlers being referred from the general population, using a universal screening in primary care or community service. Of the 2,241 toddlers, criteria is toddlers must have received a first evaluation between 12 and 36 months and have at least one subsequent eval, using 12, 18, and 24-month wellness checkups. So, the final count of the study was 1,269, and 72% of these are male. So the ratio of what we see across society is fairly accurate. During the eval, autism was not only consideration. The phenotypes include autism spectrum disorder, autism features, developmental delay, language delay, other, typical sibling of an autism proband, and typical developed. Proband is a starting point in the first person in medicine or genetics. This study used what? They labeled experts, which are doctoral level licensed psychologists, using diagnostic instruments, the ADOS, remember Catherine Lord, the Mullen Scales of Early Learning, and the Vinland Adaptive Behavior Scales. Toddlers diagnosed younger than 36 months were diagnostically tested, again every 12 months, until the age of 3. And the licensed psychologists were blinded of any previous diagnosis. And after each session, the psychologist rated one of those 7 phenotypes mentioned earlier. The results included autism spectrum disorder, N equals 441, autism features, N equals 78, developmental delay, N equals 89, language delay, N equals 80, other, N equals 91, typical sibling, N equals 51, and typical developed, N equals 439. At age 12 months was the lowest specificity for diagnosis at 0.50. At 14 months, however, accuracy jumps to 0.79. And at 16 months, it plateaued at 0.83. Considering the age, the 0.8 or so accuracy is pretty wonderful. In addition to the diagnosis at 14 months, autism, out of all of those other phenotypes, was more stable than developmental delay and language delay as far as diagnostic accuracy. In the WIN study, which involves the same University of Pierce, who is the lead contact now on this study, is essentially repeated 3 different studies, including the first one we just reviewed, but used eye-tracking devices towards geometric images, whereby high fixation levels equaled poorer clinical profiles. So in other words, the higher the infant fixated on a geometric image predicted the poorer clinical profile. And compared to other conditions, autistic toddlers have the highest levels of fixations. This included N equals 1,863, with N equals 725 autism spectrum disorder, N equals 103 autistic features. This is the largest eye-tracking sample, at least at that time. I am unsure if there's been one larger. However, the study resulted in 95% specificity. So, this is meaning few false positives. The researchers indicate the methodology used can accurately detect autism before the 2nd birthday. However, the researchers fail to recognize the harms of eye-tracking devices and nonlinear optics. This is devastating to a cell function, specifically communication systems within the cells. Remember the first 6 or 8 minutes of this episode. This is harmful for all of those components, those biological aspects we discussed. Keehn et al. From Indiana University School of Medicine, 2024. The question is, does an eye-tracking battery reliably differentiate children with and without autism? The group used EAE, Early Autism Evaluation System from primary care providers from June 7th, 2019 to September 23rd, 2022, ages 14 to 48 months. The study investigated sensitivity and specificity and compared it to expert decisions. Experts here are 3 clinical psychologists. Then they combined eye tracking and psychologist results. The average age of subjects was 2.6 years old. N equals 102 had standard assessment, so the psychologist only. N 113 had eye tracking and a standard assessment, so both tools, the eye tracking device and study and the assessment with the psychologist. The standard assessments only. So the N102 group received 77.5% sensitivity and 77.3% specificity for a 77% concordance. With eye tracking and assessment, the group received 90.7% sensitivity, 86.7% specificity, for a 90% concordance. These are using 95% confidence intervals. This is exciting data from the first 3 studies. The eye tracking methods were modeled after the Pierce studies. Plural. Multiple studies are repeated here. So the Rudling et al. From Autism in 2024 from Uppsala University in Sweden. Now remember, I just want to make a side note. The latitude here is much higher, much more implicated light. Even though the evolution of this group, people from Sweden, Norway, etc., have evolved under this high latitude and cold temperatures. However, they did not evolve with this artificial light. So they have two factors here that are really implicating. The Rudling study conflicts with other data. However, the methodology are slightly different. They used three groups, N equals 169 infants, with 129 of them with high likelihood due to first-degree relative of having autism diagnosis, and 40 for typical likelihood. The high likelihood was broken into two groups. They had N equals 35 that already had a diagnosis of autism. So the three groups are 1. Diagnosed autism, N equals 35. A high likelihood, not yet or no diagnosis, N equals 94. And typical likelihood, N equals 40. And the studies occurred at 10, 14, and 18 months old. This study suggests infants in all three groups responded to eye gaze essentially in the same manner. For validity, there was no consistency with how much nor how quickly the infants responded, differentiated within the three groups. The study notes infants in the high likelihood tended to look away quicker. The biggest takeaway for me, the study used a device again in destroying melanopsin and breaking those weak covalent bonds. However, the group suggests that the eye gaze is pretty similar across all three groups. Frankly, the last study does not seem to be as complex as the Pierce and the Keehn study. However, maybe they would disagree with that. In psychological assessment, if you can get the sensitivity and specificity around 0.9, as we saw in some of the studies, this is phenomenal. Even 0.8 is pretty acceptable. Now we saw the psychologist only using the normal instruments in the normal assessment process was in the high 70s, 77% or so. But when we add this extra test system, the sensitivity and the specificity increased quite a bit, which is optimal news for that early intervention at minimum to get the parents ready and prepared and active for the treatment, or making sure the little individual with autism is prepared to meet the demanding social world. This is foremost importance. We don't have to change the person with autism. Clearly stated, it is not right to change someone just so they can fit in. However, if society is more aware, if the child's, let's say, peers and other family members and school system is aware, then they can sort of accommodate, make changes so that the child can thrive in any system. The biology that gives us autism gives us the ability to be comfortable within ourselves. And this is our preference. This is the neuroplasticity. And there's ought to be nothing wrong with this because there's some great things that can come out of this. Now, however, I realize there's a range of autistic phenotypes and a range of different demands and challenges. This test, or these studies, I should say, offers a solution, offers hope for those more severe cases, those profound individuals, or the level 2, level 3 area. And we can minimize the negative experience that they will have. Remember that neuroplasticity. This is why it's so crucial. This is why I always mention the neuroplasticity. We get ingrained and expect negative things, and then that human thought can kick in. And it's not a good equation. If you're listening to the podcast or listening to the episode, please feel free to leave a review or rating. In podcasting, reviews, ratings, and downloads are huge. And I very much appreciate your feedback. You can contact me on X at RPS47586 for any topic and conversation with autism. You can email me at info.fromthespectrum@gmail.com. You can also check out the HOP website page that has links to all of my platforms and email address, any way you want to contact me or listen. And lastly, thank you for listening to From the Spectrum podcast.